Well, SEO already introduced that feeding the world is a complex problem. There are many, many technologies out there right now trying to improve efficiency, de-risk, and actually decrease the impact of agriculture on the environment. And I guess every day now you hear what the impact of agriculture is on the environment in terms of biodiversity, greenhouse gas emission, land use, deforestation, and so forth. And a big chunk of that is actually meat production. This also has been, I guess, advertised in newspapers. And already in 2008, the FAO estimated that we're currently using 70% of all our agricultural land just to feed livestock. With that, we also know that in the next 30 years, the demand for meat is going to increase because we go to 10 billion people, but also because people in China and India and Africa and South America become wealthier. And food is, or meat is kind of a status food, if you like. So when people become wealthier, they start to eat more meat. And that's where that 70% demand is coming from. And meat is a particularly resource-intense part of our diet and part of the agricultural system. So to give you an example, I apologize, these are sort of American numbers, but for a quarter-pound hamburger, so 120 grams, you need to feed the animal, this is beef, you need to feed the animal about 7 pounds of grain. 210 liters of fresh water. You require about 9 square meters of land and enough energy to power your microwave for about 10 minutes. So it's an extremely resource-intense product. And the reason for that is that animals are typically quite inefficient in converting their feed, grass or grains or concentrate, into animal proteins. It's very inefficient. And especially the cow is the least efficient of all. Pigs are more efficient, chicken are even more efficient, fish are the most efficient compared to plants. So we can all become vegetarians, and there's nothing against that. And you do see a increase in number of vegetarians, especially among younger people, highly educated people. I give lectures at universities where sometimes 25% of the attendees are vegetarian or vegan. So there is definitely a trend towards a more plant-based diet. But again, the FAO predicts that the next 30 years globally, the trend is actually the reverse. We are going to need more animal proteins to meet that demand. So their technology, again, could come in. And I think, but I'm biased, of course, should come in. So what we have been studying is, can we actually make meat, essentially the same tissue that you are familiar with, but in a different way, kind of bypassing the animals, if you like, because they are so inefficient. So we have designed a process based on medical technology. The technology actually was there, but never used for food, where we take a biopsy from an animal. It's a small puncture in a muscle. We take a very small piece of muscle out of that animal. Animal lives on. The piece of muscle is about 0.5 gram, has a couple of thousands of stem cells in there. And every muscle, including our muscles, have stem cells. And they are sitting there waiting, actually doing nothing, waiting to repair tissue when it's injured. And when that tissue is injured, they can multiply and they can form a new tissue. They do that in the animal, but they can also do that outside of the animal. So what we're doing, we take that piece of muscle out, we take the cells out, we divide them into muscle stem cells and fat stem cells, because some of those actually make fat tissue rather than muscle tissue. And then the most important step comes is we let them proliferate. So from Half a gram of tissue, we can make approximately 10,000 kilos of meat, both muscle and fat. Um, and that allows you to multiply the animal tremendously and thereby reduce the number of animals that you need to produce the amount of meat that we would need to feed the world. Then, of course, because meat is a tissue, it's not just cells, it has texture, it has a lot of protein, it has nutritional quality, it has taste, both the muscle and the fat. So you need to make a real tissue out of it so that it has a bite. Um, Fortunately, these stem cells are very capable of doing that. You have to provide them the right circumstances outside of the animal to make those tissues, but it's a relatively simple technique. And we have been very successful in getting consistent muscle tissue out of those cells with relatively simple techniques. We have recently also worked on the fat tissue, which is even a little bit simpler, although it takes kind of counterintuitively, it takes a little bit longer to make fat tissue than muscle tissue. So we do the same with fat tissue. So this is the biopsy from the cow. This is the proliferation of the cells, very simple. You can do that in an industrial way in large bioreactors. Think tanks that you use to make beer. Similar things, except that now cells are growing instead of alcohol being, or sugar being fermented into alcohol. So the cells grow in their large quantities, you harvest them and you let them make tissue, and then finally you assemble the tissues to make a hamburger. So here is the stages of the tissue formation. Again, the cells pretty much do it by themselves. We don't need to do a whole lot. It takes about 3 weeks for the cells to mature into a muscle fiber. For the fat cells, it takes a little bit longer to mature into fat tissue, about 4 or 5 weeks. But then you can combine them into a hamburger, which we basically did in 2013. Here you see the first hamburger that was ever made from this particular process. We presented it in London. We also mentioned, kind of tongue-in-cheek, that it cost us €250,000 to make, suggesting or illustrating that it was not a product yet, and that there were still a lot of issues with it, but basically showing the proof of principle that you can do this, and also stressing that we should think about how we're going to produce the increasing amounts of meat that we need in the future. So it was presented at a press conference and it was eaten by 2 journalists, and they said, oh yeah, this is meat. It's a little bit dry. At that time, we didn't have any fat tissue in it yet, but since then we have created it. So in order to get that from a proof of concept that we presented in London to a product, you need to design kind of an industrial process. And especially the proliferation of the cells I mentioned, this is going to be in tanks, bioreactors. You see them here on the right. This doesn't look like a brewery, but it's the tanks are kind of similar. And you need to gradually, from the very small amount of muscle that you have, from this very small amount of cells from the biopsy from a cow, gradually need to transform that to such a large number that you can fill a tank and that they can keep on growing in a tank like that. It requires a couple of changes. We need to actually grow the cells on microcarriers, which are kind of small particles that are suspended in that fluid, and the cells grow on top of those microcarriers. So at the end, you have to separate those microcarriers from the cells, harvest the cells, and let them make tissue. So to give you an idea of what that would require, if you would replace the entire world production of meat, which is about 300 million tons per year, it would require 20 million cubic meters of bioreactor volume, those tanks. And to give you an idea, currently we have a lot of that bioreactor volume for biotech, for instance, brewing beer. but you would increase that by 150% to accommodate the entire meat production and replace the entire meat production by cultured meat production. So that's a significant endeavor, which obviously you cannot do as a company alone. You need to license this technology eventually to a large number of companies that all over the world start doing this and start assembling these fermentation plants to create meat. I said that the initial hamburger was €250,000. That's mostly because it's a medical technology, and all the ingredients and all the materials that we used, and actually also the personnel, was all pharmaceutical grade, so highly trained, highly pure, and very, very expensive. In livestock agriculture, about 70 to 80% of all the cost is in the food, in the feed of the animal. And it's essentially the same in cellular agriculture. A big chunk of the cost, if not that 70, 80%, is actually in the ingredients that go into this material. So the cells obviously need to be fed as well. They need to have sugars, amino acids, vitamins, minerals to grow and to build a tissue. The advantage of doing it in a bioreactor or in a lab, if you like, is that you can increase that efficiency of conversion of their food into animal proteins, which is horrible in cows, and which you can make a factor of 3, 4, 5 better in a culture system. And that would reduce eventually the cost of all the ingredients, but also would require much less resources in terms of land and water to grow the same amount of meat. So can you get that cost down to a reasonable cost? This is a somewhat boring table where if you work on all the steps and sequentially replace all the pharma components in the ingredients by, for instance, food or feed grade components, then and you introduce recycling, which also from a resource perspective, of course, is a valuable thing to do, then you can, in the end, so if you only take care of the sort of the low-hanging fruit, recycling and the most expensive components that go as ingredients into this system, you would arrive at about €140 per kilo, which is expensive, but is already kind of marketable. What we're currently doing is looking at the next step, is in all the small ingredients, the amino acids, the sugar, the vitamins and the minerals, can we source them from non-pharma sources like feed or food sources? And those typically go down in price by a factor 10 or so. And then you get into the area where it becomes kind of on an equal basis with regular meat. So we think we can get there. We are not there yet, but we think we get to eventually price parity with regular meat. This is a novel food. In Europe, it's designated already as a novel food. It's very specifically mentioned. The novel food procedure for this has been outlined by the EU. Europe is far advanced above any other nation in that matter. However, it has to be regulated as everywhere, but here in Europe, it particularly takes long. It takes about 1.5 years to get through the regulatory approval, if you are lucky and if there are no additional hurdles. There's no genetic modification here. There can be, but we have chosen not to. Some others have chosen to use genetic modification. Has some advantages, but they are not absolutely necessary, so we have chosen not to do that. That facilitates the regulatory process a little bit, but still you have to go through the regulatory approval. So that means that in the next 2 years, there will not be a product on the market because as far as I know, nobody has filed an application yet for EFSA. In other countries like the US, it might go faster, and in some Asian countries, it might go even faster than that. So it's possible that we will, in Europe, not be the first to experience that, but it will be somewhere else in the world. When we did this in 2013, we were obviously the first and also the only ones working on this. Right now, I'm happy to say there are about 60 companies in the world doing somewhat the same thing. Some are working on pork, some on chicken, some on fish. Essentially every animal that has these stem cells in the muscle, you can use this technology for. Alessio also mentioned Shiok meats. They are doing shrimp, essentially using the same technology out of Singapore. So there are a couple of examples now. Some of them, including our company, have reached Series B funding. So they are funded in the 50 to 100 million euro, basically to start scaling up the production, start a pilot plant, and start the regulatory approval to get this to the market as fast as possible. The item that is not in the presentation, but I want to briefly touch upon because it will for sure be a question is, should we want this as consumers? How do consumers actually look at this? There's lots of debate, there's lots of uncertainty. Since 2011, surprisingly, there have been a lot of surveys throughout the world, but mostly in the US and in Europe, about how people feel about this. And what we have seen since 2011 is a gradual increase in acceptance of these type of technologies, from maybe 10% of the subjects being sympathetic to this to now roughly 50%. And it's pretty much the same in a lot of geographical areas. So you see that there is an increasing acceptance of this. Now, this is in surveys, so we don't know how the reaction will be in the supermarket yet. But we do feel that a lot of people are actually waiting for suitable alternatives for meat, because we get on a day-to-day basis exposed to the environmental impact of our meat consumption. And of course, we had been already for a long time exposed to the animal welfare issue. So there is an underlying, well-covered anxiety about eating meat that can be relieved when there are credible substitutes. It will compete with plant-based meat analogs, of course, and that's a good thing. That we will see how consumers will react to both of them. We feel that there are quite a few out there who actually want to eat meat and not substitutes. And this is also a technology that allows you to eventually make a full thickness steak or a ribeye and that's, I haven't seen credible alternatives in the plant-based area recreating that type of product yet. So with that, I would like to conclude. There's now a much bigger chance that this is really going to take off with this number of companies, with the investments going into it. And I think we should be looking forward to this, because otherwise we will have a big problem with meat production and meat consumption in the future. Thank you.